This is a revision to the chapter 3 from AP Physics. Our topic here is a projectile motion. So projectile motion. So here we have, let us say, projectile that is fired, and then it drops at some distance r. When the projectile exits this nozzle, it has got some initial velocity vi. So the projectile has got two components. So this is in x-axis, this is in y-axis. So when the projectile exits this nozzle, then it's accelerated downward at every point because the gravity is acting on the projectile. So this projectile has got two components. One is a horizontal component, one is a vertical component. So the horizontal component is not affected by gravity, so it will remain same. So Vx will remain same throughout the journey of the projectile, whereas the Vy, the y component of this initial velocity, will be affected. So as the projectile goes like this, so the vertical component goes slows down, and here it becomes 0, and then after that it increases, it may become maximum here. So so this is what happens to the vertical component. So let us find here the time for the flight. Time for the flight is the time taken by this projectile to reach from here to here. So we can find a time, we can find a range. Range is the distance the projectile traveled after from the nozzle to the distance r. So we consider here r. We'll calculate r, and then we'll calculate this height, the height h, the height that the projectile covered while it was traveling. So h. Let us derive the time first. So we can find time by considering a second equation of motion. So we write s is equal to vi t plus 1 over 2 gt square. Here the acceleration is a constant, so g we'll consider here. So when the projectile goes up, it has got initial velocity, which is from the components here. So let me just zoom it here. So this will be theta, this is vi, this is vx, and this will be our vy. So from using a trigonometric ratios, I can write my vertical component vy, which is simply vi sine theta, and similarly vx is equal to vi cos theta. Then I can substitute the initial velocity of the projectile here. Since I consider the vertical, I consider a case where the vertical component goes up and comes down, so the total displacement here is 0. So the initial velocity will be vi sine theta, and t we need it. Here we consider minus g, so this expression becomes gt square. Then we can simply solve for the t here. Then the t will be here. By solving for t, we get 2vi sine theta divided by g. So this is our time. This is our time for the flight from here to here. Then next we have here is the range. We can find the range by taking the velocity, horizontal velocity component, which is vi cos theta times t, time of the flight. So vi cos theta, time of the flight, we just found it, which is 2vi sine theta divided by g. Multiplying these, we get here 2vi square cos theta sine theta. If I close up 2 cos theta sine theta, this is a trigonometric ratio, here is g. Then this becomes vi square sine 2 theta divided by g. This is my range. So the range, which I wrote in terms of initial velocity and theta and gravitational constant. Then we can find h here by again writing the second equation of motion that we wrote here. We'll just plug the values for initial velocity and time. For height we have initial velocity is vi sine theta, multiplied by time we have here is 2vi sine theta divided by g minus 1 over 2g, then substituting value for the time, which is 2vi sine theta divided by g whole square. So if I simplify this expression, I get h. The height will be vi square sine square theta divided by 2g. So this is my expression for h, and this is my expression for range.